It's more. Guys, I'm very happy tonight to have the whole POKT team, some POKT friends, believers, investors. I'm Laszlo Sabo, the CEO of SkillZ, and we're running POKT nodes for more than a bit less than a year now. I met Michael, right, in 2019, Berlin Blockchain Week, and he first explained what POKT was and what was the old philosophy of it. In beginning of 2020, we just had a call, and I told him, oh yeah, come to Paris, man, and let's do an event for ETHCC 2020 in March. We were running private nodes at the time, and the event was quite different. And during first quarantine, you told me, hey man, would you like to spin up the network with us in August? Mainnet is going live, and we need the infrastructure provider to do it. And it turns out to be one of the best choice we made. And again, like betting in the philosophy of having a Web3 infrastructure, decentralized way to access blockchains. And now we started with 75% of the network. Hopefully we don't have these shares yet, so it's less than 20%, and we will surely have less and less, and the network will surely be more and more decentralized in the future. But we kind of very happy to kind of fest the 1 year. It's going to be next week, but let's assume it's tonight. 1 year of mainnet. So again, very, very happy tonight to have Adam and Valeria that's going to talk about this 1 year retrospective. Michael will talk about what's new on POKT and a little bit of the DAO. And last but not least, Sebastian, one of our lead DevOps, that's going to talk about POKT topology. So please give a big round of applause to Adam.
Thank you so much. So my job here tonight is to basically take you through about the last year of POKT Network. But first, I'd like to just quickly introduce myself. I've been with POKT for about 2 years now. I have this kind of affinity for kind of the intersection between entrepreneurship and technology, so that's why I'm here at POKT Network. I'm partially French, which is the French connection here, and I've got a few other things. I am a cat dad, and I've got no casual headshots, so this is why you've got this horrible image of me. My role here at POKT Network is econ and operations. And so I'll launch right in. For those of you that don't know, POKT is a blockchain agnostic, decentralized infrastructure platform. And so what that means is we're basically your one-stop shop for our decentralized RPC endpoints. And I'll keep going here. Sorry, I'm skipping ahead. So let me get to the origin story a little bit. We began building smart contracts on Ethereum in about 2016, 2017. We were playing around with Web3, and then we realized very quickly how much the ecosystem was reliant upon Infura and how bad that was for a decentralized network. And so we created this thesis around decentralized infrastructure. We spent the next couple of years building the team, publishing the white paper, building out testnets, MVPs, and eventually mainnet, which was, as Laszlo said, about a year ago. And so you're probably wondering, okay, great, so how does it work? And I am using one particular use case. There's a couple different ones, but for the purposes of this presentation and setting up Valeria for later, we're going to talk about accessing via the portal. So we've got a little bit of symbology here. Applications connect directly to the POKT portal. The portal kind of sends those relays on, and so your requests onto one or more session of POKT nodes. Those nodes end up communicating with external blockchains like Ethereum or Polygon, so on and so forth. And then the requests end up coming back. We call them relays, so if I slip into our lingo, that's why the requests end up flowing back through the system back to your application. And again, this all happens through a decentralized network of nodes and the POKT portal. So you're probably wondering, okay, you've got a token, right? So like, what does the token do? Our token is POKT. It's called Pocket or POKT, depending on who you are and what kind of time of the day it is. So app users, basically you're rate limited by the amount of Pocket you stake on the network. It's very simple. We rate limit by session, which I won't get into as much. But essentially think about it as you need a certain amount of Pocket for a certain amount of usage, and it's very proportional. For nodes, Pocket gives them access to run as a node runner. So your node stake is 15,000 minimum. And you do that as kind of a security deposit to keep you acting in good faith and prevent any bad acting. And so you're probably wondering, like, okay, so why go through all this effort? Why build this decentralized infrastructure? So on and so forth. So we kind of believe in this philosophy of relying on a protocol, not a company. So if you rely on one of our competitors, you're relying on essentially layers and layers of backups. We eliminate all that backups, cut down on price, and increase redundancy. So we don't really suffer from downtime, we suffer from degradation, which means that some nodes in your session is bad, and we send those back to our failover nodes, and so you basically end up with what is 100% uptime at all times. Additionally, we've got no kind of real middlemen. We've got fair pricing, so no real sunk costs. If you don't like Pocket, you can take your Pocket, unstake it, leave the network, go sell it, and you're probably better off for it. We also, by sending your requests to various sessions, and you can do many, many sessions, which means you send it to many, many, many nodes, you're splitting your requests across a bunch of different nodes, which means no one's got a clear picture of what you're actually up to, which means you've got a super private, super secure connection. Additionally, Pocket is governed by the users. So we've got the Pocket DAO, which is a pretty strong representation of the users of Pocket Network, and they vote on all the basic parameters and issues. So let me talk about the last year. So we ended up wrapping up incentivized testnet about a year ago and launching mainnet July 28th, if I'm not mistaken. Along with this, we ended up releasing a few of the first products and an MVP of our governance system, which is the Pocket DAO. Since then, we've been hard at work on new revisions of Pocket Network or Pocket Core. We've released a new product or a new process that allows us to spin up new chains in a matter of weeks, if not, at most a month, depending on how long it takes to sync the network. And we are working on the final stages of Wrapped Pocket, which will be a farming tool for a farming app, so that applications can further subsidize their infrastructure by their users. I'll let Michael kind of carry us forward and talk about all the new and exciting stuff, but I'll kind of hint at it right now. So where are we at today? We've done about 2 billion relays, which is a drop in the bucket when it comes to infrastructure, but it is an indication of traffic and traction on Pocket Network. We've got about 4,000 nodes today. We kind of fluctuate between 4,000 and 5,000 nodes, so we're easily the largest Tendermint chain or Tendermint fork in the Cosmos ecosystem. And we've got about 12 chains about 3 clicks away for developers. And that's all thanks to the Pocket portal. So I'm just going to real quickly, maybe. Oh, I'm going to take you, here we go. Okay, I'm going to take you real quickly through some hard-fought lessons, just as kind of a debrief or a post-mortem about the last year or so of Pocket Network. So my first point is, this shit is really, really hard. You're building not only a company, you're building basically what amounts to be a country, an economy, governance system, and it all is really, really involved, and it takes way longer than you think it will. Another takeaway here is cool tech isn't everything. Relationships really matter in this business, and we shouldn't kind of discount that. At the end of the day, it's all about people, and it's all about what they need. And so you've got to really cater to individual needs, and they're not going to want to lose their job over what amounts to be like really cool tech. We've done really well with kind of our scrappy persistence, and I would encourage all of you that are out there building something to keep up that persistence over the course of time. That will win over hearts and minds of your ecosystem. We've been kind of blessed in the way we've kind of gone through things, but we've always done the thing that gets us to the next milestone, which allows us to do the very next thing, and that's really been an important part of our story. Finally, I'll wrap up with these. Like we've been focused really hard on, in the last 6 to 12 months, of building the foundation of Pocket Network. That sets you up for the rest of the entire protocol's life cycle. So if you do it wrong the first time, it's probably not going to be good. You're probably not going to have a good time. I will say that it takes a village. Our core team is great. We've got very talented individuals, but you need outside contributors. You need people that have different perspectives, and the core team can only take you so far. So invite the people that will add value into your ecosystem and put them where they can add a ton of value. We believe that genius is everywhere. We have a highly diverse team, but that doesn't only end at the team. It also ends at contributors, people in the DAO, things of that nature. And everyone has something to contribute in their each little own way. We encourage you to find clear roles and then put them in the seat in the bus that that benefits the protocol the most. And I would encourage you just to kind of meet them where they are. And so with that, I'm going to hand things over to the lovely Valeria, who's going to take you through a little bit of the Pocket portal.
Yeah. Thank you. We're going to try to set up a demo. We didn't get a chance to set it up before. If anyone has any questions about how the protocol works or anything like that, while we set it up, but happy to answer anything while we set it up.
Okay.
This one?
Yes, that one. Yeah.
While they're doing this, I'm happy to take any questions if anyone in
Yep.
the audience has.
Very good.
This should be fine. It works. Amazing. It's the demo side. Demo effect. So is it broadcasting?
Yeah, I don't want to be too obvious, but I'm fairly new to Pocket, and so I was wondering, like, should I see it as a competitor to Infura, or okay?
Yeah.
Can you present it, please?
So that's a good question. We are a direct one-to-one replacement for Infura, but we do a bunch of different chains that Infura now doesn't support. So
Thank you.
when you're thinking about where we come into the ecosystem, that's pretty much right at that intersection.
Silly question. How do you guarantee SLA?
SLA?
Yeah.
Yeah, great question, and it's something our competitors do that we do not. We rely upon the benefits that we have in the protocol to guarantee some sort of uptime. We don't provide any service level agreements or anything like that. And we may in the future, but not at this time.
But do you have any guarantees? Like, my request is served by random nodes in the network, or how does it go?
Yeah, it's pseudo-randomly selected. So the question was, like, how are the nodes in the requests kind of like divvied up throughout the ecosystem or throughout our node network? They're pseudo-randomly selected, so you get paired with a session, and it could be multiple sessions depending on how you configure your stake. And that pseudo-random selection puts you in these groups of sessions, and that's how the relays are distributed.
Yeah, you get integrity guarantees on the integrity of your data through two ways. We use zero-knowledge range proofs to make sure that the nodes aren't lying about the amount of relays that they do. And we have a challenge system between the application and the nodes that they're with. So you can think of it as like a rough consensus. We have sessions with groups of 5 nodes. So if one node answers with an answer of, you're getting a balance, one node answers with an answer of 20, the other 4 answer with 15, the application can actually submit a challenge transaction and have that node be burned. So that's sort of the 2 ways that we ensure the integrity of the data itself. We kind of have the SLA at a protocol level, if you will, in terms of the redundancy and the integrity of the data itself.
Okay, so there is a consensus on each query, right? As you said.
There's only consensus when the application wants to do it. It's not enforced. It's pretty flexible in that sense. So otherwise, that would be very expensive. Yeah, and it's stateless. So the nodes within the session are not communicating with each other as well. So it's up to the application to decide whether they want to submit a challenge or not. Yeah, yeah. Hopefully that answered your question. Yeah, yeah. Yeah.
Any more questions? We'll take one more.
Yeah. Cool. Good to go? No?
Very shy, and when you try to show them, suddenly
We're actually
something
going through a timescale DB upgrade right as this was starting. So as a result, some of the data wasn't showing on the dashboard that we're about to show you guys. So
Good. So then let's start a little part from my side. Who am I? I'm Valeria. I'm one of co-founders of POKT Networks. I'm an industrial designer that turned into the blockchain space some years ago. And since then, I've been very motivated to work in this space and put my design skills in service of providing more usability to the network. What do I do in the team? I design. I work in branding, I work in product, UI, UX, and sometimes I extend my hand still marketing to use some visual help to communicate and get closer to the users, bringing, again, usability to all the products that we create. We are trying to build a product for the users, and as Adam just mentioned, we face a lot of challenges every day. One of those challenges in the product side is how do we get this closer, how do we lower the barrier of entry for applications to the Web3 infrastructure? How to make easier for developers, for creators to access to this network of really decentralized applications. We have these very robust networks of full nodes providing high quality infrastructure, and we have applications with very creative solutions that they don't need to really run this infrastructure, these networks, and they don't really need to run nodes. We let professionals and we let people that are interested in running really infrastructure to access to it. How do we do it? That is our challenge. How do we give them an easy access to this infrastructure so they can really concentrate and they can really focus on building awesome products that bring closer the blockchain solutions for normal users? Like, we are users more specific of technology, but we want to get applications to get closer to more mainstream users and give more better experience of the blockchain to everyone. So we did it, we think about it, and we create a product. We create a UI where we give access to the network in a platform where we provide some access to application and nodes to the actions in the network. But fail fast, they said. We try it, we test it, we build it, and we saw like we make it very complicated for users. We try to achieve a lot of things. We try to provide a lot of things through the dashboard, and it was good. It made us grow, and it made us think differently, because these applications need solutions, fast solutions that they don't take care of a lot of information that probably are going to distract them and make their journey through access the infrastructure longer. So right now, yeah, here we are. Today, I'm going to present you our new product, like this is what we are currently working on. That is the portal, the POKT portal. Why do we call it portal? What's a portal? It's a gateway, it's an entrance, it's a way to go to other space. Our goal or objective is to create this, a way to access to Web3 infrastructure to any developer, to make this product a way to allow anyone to build on Web3. I really don't have to take care of all the infrastructure side, but just an easy building tool. Right now, let's go over some screenshots. My intention was to go over the product, but we're having an issue. So let's go over screenshots because it's a better backup. It's very easy, just a simple registration. You go, you verify your account, very easy, and then you're in. Once you're in, you are going to have this view where you just have to give a name to your application. Simply identification, you select one of the, one of the 12 networks that we have available for users to connect. Right now, we have available users to connect to Pocket Network, Ethereum, Avalanche, Polygon is something coming very soon, XDAI, Fuse, and Binance Chain. So just by selecting one of those networks, you are going to then click and launch application, and you are in. You are getting an endpoint ready to use. You copy and paste it, and you replace it for your old legacy endpoint, and your application is ready to relay data into the network that you selected. This example is connected to Ethereum, and this application will be able to run data to Ethereum very fast, just like that. Here we have a small dashboard when you have some valuable information for you to track what is happening with the infrastructure that you are driving your application, because that's also a problem that we saw. Developers need to be realizing where is their infrastructure going and how it's behaving. Very fast, let's go over the information. First sections give you the success rate and the latency, so how fast is responding the network to the calls that you are doing. And if you click in more details in this part of the panel, you will take a look, a diver look of the request, which one succeed, which one go fail, and you can classify it and take action on it depending on whatever errors you're having. If we go back and we scroll down a little bit, we are going to see the current use and the weekly use, an overview of how your application is going. You have to take care that your application don't go over this 1 million relays, because that is what we are right now subsidizing while you deploy an application, when you connect an application through the dashboard. So that's the limit. If you go above that line, then your application will need more relays, and you have to find a bigger solution with our sales team. If we take another look to the panel in the other side, oh no, if we scroll down, there's more information. We have latest requests, there's some organization of the information, and you can really take care of what is your application behaving, how is consuming the data that you are relaying. And the panel on the side, we have some major CDAs. The first one is the application security that we have on the top, and is an extra layer of security that we suggest every application to have on. And the second one and the third one is the white agents and the white origins, just to protect where the data is coming for your application. Make sure you save your changes and you go back. And the other setup that we allowed is to click the notification setup. The notification setup allowed users to make notifications upon their consumption of the infrastructure. We have very easy toggles, turn on and off in this percentage, and you will get an email when your application go around those limits of consumption of the infrastructure. And last but not least, we have the network overview here. We have a general reading of how is the network behaving, what is running, and right now, this is a screenshot based on design, but right now, I'm glad to share with you that we are over the 18 million relays served this week. So this is dummy data, but real data is above 18 million, around that. What else? What other data we have here? If we scroll down a little bit, we are going to see the available networks that we have. Right now, you will see more than 12 networks, and also different nodes where you can connect it. And here is again some closer look. And here are the networks that we are supported and how they behave in our network. Right now, we have nodes and applications staked for each one of these networks. And we're very excited that soon we are having more networks joining this list and more applications staked on the portal. The summary in general, today we have more than 600 applications registered on the portal, and we have a stake over 500 applications, and we are relaying over 40K relays in the last 7 days. And I will update this data because this week we go over this, this number. What is our product vision? Where do we want to take this product? Right now, as I mentioned, users just can log in, get an application, get an endpoint that is fully subsidized by POKT Foundation, and get 1 million relays to drive their relays. But our idea is to make this product your product, to encourage others to replicate the same product and run their own gateways, run their own portals for themselves, for their products, or maybe for their businesses. Because our idea and our project vision is always to encourage others to build on top of what we do. So that's it, that's the product. Let me take another look, but we didn't get it. But it's going to be working in a couple hours, I assure you. Mike, I get it's you now.
Is it working? No.
No, it's not that
Whose
one.
phone is this?
It's this one.
Never mind. Hi, everyone. Thank you, Vala. Thank you, Adam. And thank you, Laszlo. Thanks for coming. I'm just going to talk about a couple things. But first, a little bit about myself. Been in Bitcoin since 2013. Studied international studies in college and taught myself to code. Changed my life. We started writing some smart contracts in Ethereum back in 2016. And that's really that's the best $5 I ever spent on that avatar. So what I do, I'm the CEO of POKT Network Inc., which is the company that built POKT Network and strategy and hype man sometimes. So I'm going to talk first about the DAO. POKT has a really unique governance system. Adam mentioned that we're building a country, and that's kind of how we thought about designing the governance system of POKT. It's a permissioned democracy. So we don't do token-weighted voting in POKT. Anyone can actually claim a vote. Permission, and I say permissioned because you actually have to complete some quests to actually prove that you have knowledge of the protocol that you've participated and done so. So what I mean by that is, if you're running a normal node, you submit a series of quests through the POKT Arcade on our Discord. You can think of this as like the metaverse, if you will. And this is what allows our governance system to be civil resistant, so that you can't create many identities, for example, and have many votes. It's actually one person, one vote. We use things like Bright ID, and really it's really hard to automate any of this. So it'll probably get progressively more difficult over time as people do it. But we've seen some awesome success. We have 14 voters. We started out with 5, so 9 people have claimed their votes in the last year, which is really cool. 22 proposals, and about 500,000 POKT has been granted for various tools and these sorts of things, and 100 arcade quests claimed. So it's really cool when you see people submitting signing from their nodes. I've been running my node for 3 months, for example, and you just go ahead and sign it and with your private keys, and that's your proof, and it's really cool. So that's a quick update on the DAO, and there's different paths that people can claim votes. You don't have to be a technical person. You can be a community member and kind of help on marketing and BD and that kind of thing, and actually claim a vote in the DAO. So it's something that we're really excited to see how this evolves over time. I want to quickly talk about the next 12 months. So really, we're just adding a lot of chains really quickly. We added 10 at once a couple weeks ago, and we're really excited about all the layer 2s, really excited about products like IPFS and Ceramic, because you actually basically have Amazon S3 decentralized with POKT and something like IPFS or Arweave, or Ceramic is super interesting as well. So we're really excited about POKT and how it can incentivize people pinning this information on their local nodes and this kind of thing. And of course, Once we get through kind of these early ones, we definitely want to move towards supporting parachains and tendermint chains and these sorts of things. And we really see Pocket as kind of one interface to access Web3, to be honest. There's going to be a couple new models, business models that come up in the next couple of months. So the portal that Valeria just showed is completely open source. So anyone can take it, copy it, and run it themselves. Someone asked about SLAs earlier. We have some people that are running, trying to run the portal and for enterprise customers, for example. So people can actually become their own infrastructure provider without actually having to run the infrastructure, because you're just passing through the requests to the network itself. It gives you a very big competitive advantage in terms of pricing and this sort of thing, because effectively when you get these million relays, we're just staking our own pocket in the back end there for you. So and all you need to do is change the amount of pocket that you're staking, or however it is that you decide to do your model. So really excited about that. In a couple of months, we're launching Wrapped Pocket. This is really exciting for us because it's actually a way for people to crowdsource infrastructure. So this will be an Ethereum token, ERC20, and we're using the Token Geyser smart contract from Ampleforth. And effectively, you'll be able to stake on behalf of applications that are already on Pocket. And those applications will be able to basically take those relays that were staked for and basically have a permanent free tier should they decide, which is pretty cool. Since Pocket's it's a tendermint chain, it's an application-specific blockchain. We're actually working on building the bridge now. The actual Wrapped Pocket app is built and ready. So we're just figuring out the right way to build the bridge at this point in time. So we're really, really excited about that. And then in the next 36 months, one thing that we've really learned over this last year is this shit's really hard. And we've really, we're kind of seeing this first iteration of the protocol as more of beta. And we've been really working on thinking about Pocket 1.0 and what that looks like. We're hoping we can have that out by next year. But for example, today Pocket doesn't support WebSocket connections. We can't have unbounded service nodes, even though that's what we designed the protocol around, to have thousands, hundreds of thousands, or even millions of nodes around the world. What that will allow are things like Pocket US West, Pocket US East, Pocket EU, et cetera, et cetera. But we need to reach a critical mass of nodes around the world to be able to do that. So Pocket 1.0 is really, really excited. It's something we're really, really excited about. And I think we're going to be releasing some of the protocol talks of the team kind of thinking about this and kind of how we're thinking about solving this problem. So yeah, that's kind of a quick overview, really, that I wanted Adam and Valeria to really kind of show off what we were doing. But yeah, thanks for coming. Happy to answer any questions. Like I said, the portal's, it's open source. You can check it out. Definitely recommend. So we were having problems because we're actually upgrading our timescale database at this exact moment in time. So the data wasn't showing, which was kind of painful, but either way. So but yeah, thanks everyone. Huh? It works. Yeah. Yeah. Yeah.
The applications, they have the JS data.
So yeah. There we go.
Move again? No, the other, yeah, the other one.
I don't know the login password for this.
You launching products faster than you can learn.
Yeah. Oh, there we go.
Here.
There we go. Oh, there we go. So this is one of our users. We're integrated with Ethers.js, if you're familiar with it. Hopefully the data loads.
So, launching an application very, very fast is as easy as giving skills. Then we want to connect to Fuse. Come here, have security, turn it on, or extra security, go back, launch an application, and we should be getting an endpoint to copy and replace it in the old legacy endpoint.
So we basically pre-staked Pocket to allow this to happen really fast. We have 15-minute block times, which is kind of different in the space. We're not a transactional cryptocurrency. It's really just meant for applications to use really reliable, redundant infrastructure, full node infrastructure. So yeah. So it's kind of working a little bit. We're getting there. But yeah, so if anyone has any questions or anything, anyways, thanks for coming. We have a bunch of T-shirts. We have beer. I think we're all going to go to Ledger Party later, hang out. So yeah, thanks, everyone. It's not working. Well, we got some network data here, which is pretty cool. So PC, we're doing about 18 million requests a day on the network right now, which is pretty cool. So yeah. Cool. Thanks, everyone. Oh.
This is more of like a broad question, not really specifically for Pocket. But with the recent like graph going decentralized, and there's more services like API 3 who's trying to decentralize API access, and now with the Web3 connectivity becoming decentralized, what do you think is like the next kind of area for Web3 stack to kind of focus on for decentralizing the access, or any other services?
Yeah, I think things like Handshake, ENS are huge. Privacy, things like Hopper, NIM, these kinds of protocols. I think basically like the base layers are decentralized, but what's happening is that we're getting kind of bottlenecks as we go up the stack. So I think we're going to see many different kind of verticals with dozens of protocols under each vertical, kind of trying to solve a specific solution. Personally, so.
It's more about just crowdfunding. How is it going to work for the normal users? First of all, why would they do that for the protocol other than they like them? And second one, if a lot of them get out of it, and then the protocol doesn't have enough stake anymore, are you going to warn them in advance? Like, how is it going to work?
Yeah. So I'm just going to repeat the question. So the incentives for
incentives for basically you said for the crowds
funding,
for the pocket. So you're going to have users basically stake the pocket to help a project.
Yeah.
Other than the fact they love that project, which is always good, but they're always going to be like, what's in it for me?
Yeah.
And the second one's like a lot of them kind of like get out after. What's going to happen for the project?
Yeah. So we're going to over collateralize the stakes. We got approved. I think it's 10 million pocket by the DAO. We're going to put a good chunk of that in the smart contracts. And you'll earn some yield, basically, for staking on behalf of applications. So it's a bit of an experiment for us. If it continues, we'll continue to fund it if the community wants it. For context, the way the rewards work in Pocket, the DAO actually receives 10% of all inflation. So if the DAO wanted to allocate 0.1% and kind of feed that into the smart contracts, well then the DAO could if they wanted to. So. And can kind of keep funding that in perpetuity if they wanted to. So, yeah, and making sure we're over collateralizing the stakes so that if someone wants to unstake, doesn't ruin everything as well. So, yeah, cool, good questions. Thanks, everyone. I think Sebastian is up next. This guy's a fucking wizard.
Cool introduction slide, but briefly, my name is Sebastian. I've been working at SkillZ for about 4 months now. I'm working on the infrastructure side, like basically how we run validators for different customers. And I'm going to talk about how we do it at scale. So yeah, just a brief overview of the agenda. So it's going to be a bit more technical than the previous talks. And like if you want to leave, like feel free to do so. I'm going to talk a bit about Pocket and SkillZ, then about topology, which is a problem that emerges when you start having a lot of validators. Then I will talk a bit about automation and finish with instrumentation, like monitoring and this kind of stuff. Okay, so Pocket is a proof-of-stake blockchain where validators get rewards by serving requests from different decentralized applications towards other chains. The mainnet started about 1 year ago, and as of today, there are about 5K validators. So it's a different number than the one from Adam, but I think I checked like 1 week ago when I started making the presentation, it was 5K, but it fluctuates a bit. So this is the basic model of how it works. Yeah, there is a gateway missing here, but I just simplified it a bit. So you have decentralized applications. They target Pocket validators, which are connected to different blockchains, and the validators are serving requests, and in exchange, the validator gets some portion of Pockets. Yeah, so that's the basic model. So our job here at SkillZ is to run those green validators and also the backend side, and like be able to basically scale this part here horizontally so that we can have like thousands of validators. Well, this is what I just said. So yeah, as of today, we have about a bit more than 1K, probably 1K and 400 validators running. So let's talk about topology. So Pocket uses peer-to-peer, like uses Tendermint, like a fork of Tendermint for the peer-to-peer communication between nodes. And topology is basically how you organize your nodes so that they have good peering together and they can like contribute in a good way to the network, because network stability is something very important. And there are different approaches to do this. And usually when you run 1 or 10 nodes, it's not a problem. But when you start running hundreds of nodes, you start getting big issues in this area. So you need to have like some sort of constructs. And we are going to see different approaches. Yeah, this is kind of like how we adapted a good talk from Ben Van, who is also like a guy, like a good guy of like the Pocket community, who made a 1-hour talk about topology. So I'm reusing some of these ideas, but like if you want the full story, I think his presentation is very good. Yeah, same slide. So yeah, as I said, Pocket uses Tendermint for peer-to-peer communication. Peer-to-peer was made to run like hundreds of nodes at most globally, and Pocket uses like more than 5K validators, which means that there are a lot of issues that arise because of like the initial implementation of Tendermint was not ready for this kind of usage, and which is why Pocket uses a fork of it. So yeah, so this is how it works when you basically run one validator. So typically what you are going to do when you start the validator, you are going to connect it to a seed node, which is a node that has like a good presence on the network and knows about all of the peers, or not all of them, but a big portion of the network, and it will output a list of nodes to connect to, and then the validator is going to connect to those nodes and get more peers and discovers the network little by little. And this is what is also called PEX reactor for PEX exchange, peer exchange. And this is somewhat automatic, as in you just connect to a seed node and then your node is going to make its life. So yeah, and once it's connected to peers, it will start getting blocks and distribute them to its peers, and like things are going to go well. So this setup is very easy to put in place because you don't need to have like specific constructs. It's dynamic. You don't need to edit your configuration in weird ways. You just need to like point your node to a seed node, and then things are going to work. But it takes some time to have peers, and you have basically no control about the quality of peers. So if you have bad peers, let's say you run 1,000 nodes, maybe 10% of them are going to get good peers, which means they will get good performance and good rewards. Whereas, but it's not going to be like evenly distributed across all of your nodes. So when you run at scale, you have like this sort of issues. You are aiming to have like some sort of stable network, but you can't get it if you go with this approach. So this is what most node runners use, like the sort of approach you use at scale. So the Pocket validators are here. They are like directly connected to full nodes, which are then directly connected to a tower node. So the tower node can be seen as a sort of a highway on the network. It's like a node, or a set of nodes that are like highly connected to other big node runners. And by connecting to them, you will get a lot of good peers and this sort of things. There are two levels here because the links here have to be statically defined in configurations, which means that if you run like hundreds of nodes, each time you add a node to your network, you will have to edit the configuration to add a new link here. And you basically don't want this part of the network to be unstable, because like if you have to restart it 5 times a day to add nodes, like your setup is not going to work well. So this is why people use a Sentry approach, where to add a new node, like you basically batch creation of nodes and create a new Sentry node, connect it once to the tower, and behind you have flexibility to restart it way more easily. I don't know if that makes sense so far. I'm going a bit fast. Okay, thanks for the support. Okay, so the pros of this, well, the advantages of this approach is that it's scalable and stable, but as I said, it requires quite a lot of manual work. And when you do it like with 1,000 nodes, it's not something you want to do. Like you don't want to manually add new centuries or have to touch configurations every time. I'm going to talk a bit more just about this part. Like this full node, which is something that has to be very reliable. As I said, it's kind of like a highway on the network. And if this thing goes down for a big node runner, then connectivity of the entire network may be impacted. So it has to be very robust. And usually what we do, so this is what we do at SkillZ. Our tower is actually 5 nodes, which are interconnected together. So each node is connected to all of the nodes of the tower with like static configuration. And each node is watching its neighbor to be able to detect if there is an issue with the current node. So basically, by looking at the block height of each node, you kind of know your current state. Like you know if you are ahead or if you are behind. And if you are behind, then there is an issue, and you probably want to automatically restart your node. And this is what we do basically. And so this kind of structure is quite cool to work with because, like, if you want to make an upgrade, you can shut down 2 nodes. Like things are still going to be fine because there are still 5 nodes. We pick 5 because we want a lot of flexibility on this side, but like some people use 3. It depends. Yeah, so this is actually the topology we use at SkillZ. So as I said before, one of the biggest problems of the sentry approach is that you have to manually create sentries and connect them to nodes, and this is not something we want to do because we want to be able to start new nodes within like 5 minutes or so we need something automatic. So what we do, we create 2 towers, like a public one, which is like the highway to other nodes on the network, and a private one, which is interconnected with the public one. And this one does not have access to internet. It's only like an internal tower to which only our validators can connect to. So basically, this one is set in open bar mode, where it accepts any connection, but we trust all of those connections because it's a private network. And that way, we are able to start hundreds of validators without having to change the configuration of any of the static parts of our topology. And yeah, we basically connect validators to 2 nodes of the mesh so that if one of them goes down, connectivity is still okay. Okay. So I think, yeah, the next steps, as I said, Tendermint is not made to run like hundreds of nodes like this. And I think like there are some features that could help a lot, like new configurations or this kind of stuff. So I think it would be cool if we could like maybe add a way to feature peers by subnets in the Tendermint configuration of this kind of stuff. So I have a lot of ideas. If you want to scale up topology-wise, I can. So yeah, that's for the first part of the presentation. Do you have like any questions on topology? I know I was a bit fast, maybe, or.
That's very good. Do you have questions?
I have a question. From where did you get the ideas to think of this topology?
So it's mostly an extension of what Ben Van is doing, basically. Like his talk from the topology was like what I described a bit before, but not dynamic. And at SkillZ, we really needed to have like something dynamic because we want to be able to spin up nodes within minutes without having to set up a configuration in place. So that's, yeah, a kind of adaptation of his early work. And you also can find quite some documentation about these approaches in Tendermint's configuration, Tendermint's documentation, but it's not made for like 5,000 validators. So a mixture of Tendermint and Ben Van.
and do you take inspiration from, I don't know, models from the nature or that kind of thing, natural models?
Underlying question, yeah. I read some papers about how trees, mushrooms can these huge mushrooms that spawns like kilometers and like, I forgot the English name for it. Is it slimes? Anyway.
It's like mushrooms.
Yeah, mushrooms. Like if you read about mushrooms, they also have like topology construct and all because they need to be resilient, and like if you cut them in two, they are going to make their own lives, kind of spread in different directions, and it's quite interesting. I think there are some parallels.
What kind of mushrooms were these?
I forgot.
And you have these kind of mushrooms after the talk.
Yeah, it's under the swag. Okay, now let's talk a bit about automation. So I'm just going to describe one automation mechanism we have in place, but we have many different ones. It's one way of doing things. So as I said, we want to have nodes that start within a few minutes or so, and synchronizing, when you start a new validator, it has to synchronize from the chain, and the chain is 30K blocks or something. And if you start from block 0, it's going to take days for the node to synchronize, to download basically all the data from the blockchain. And the blockchain actually is currently 60 gigs, I think. 56 or So it will take time. If you go by using peer-to-peer communication, because it depends on your peers. If you get bad peers, it's going to take 10 times longer, and so on and so forth. And we want to be able to start nodes within 30 minutes. So what we do is we have nodes that are already synchronized. We call them sync nodes. And every 2 hours, we stop them, and we push their data state, which is the blockchain, to a S3 bucket, from which our validators can then start immediately after. And so when the validator is going to start, it will already have a dump of the blockchain at a quite recent state, and it will only have to synchronize at most 10 blocks or something like this. So it's quite a fast way of doing things. So we started doing this that way, and we had issues at scales where sometimes nodes can crash, and if they crash in the middle of, let's say, I don't know, they can, for instance, use too much memory at one moment and be killed by Unix or whatever. And if it happens at the moment they are writing to the disk, the database is going to be corrupt. So what we are going to push on S3 is going to be corrupt. And so we had some outages like this. So to increase reliability, what we are doing is we start 3, while a crashed bucket is going to decrease with time. And so yeah, that's one way to approach automation. Anyways, let's continue. So this is a graph of our sync nodes. This is the current height of the node compared to the network. So you can see it makes little steps. It's whenever a new block arrives. And the vertical stripes are just whenever we stop the nodes, push the state to S3, and then, we have automation for different things. So we have automation for late nodes. Whenever a node is late, we are going to automatically restart it. Staking, to stake, whenever a node is not staked, and at head, we are also going to stake it automatically. So yeah, all of these things are things because we manipulate thousands of nodes, there is no way we can say change the machine type of one node 1,000 times. So we need to have some sort of scalable automation for this. And yeah, this is a small list of what we have behind. Any question on automation or? Yeah.
Yeah, I guess it's kind of a more of a general point, but I guess it'd be interesting to know how different it is to support Pocket to maybe any other networks that SkillZ supports in terms of all the automation and the things you're doing. Is it extremely unique and kind of proprietary just to focus on Pocket, or?
Yeah, so we use Kubernetes, and there are some parallels. Basically, everything that is Cosmos-based is going to use Tendermint. So the topological constructs here that we have for Pocket, we can reuse them for other networks. And then, the concept of a Jade node and staking and all, this is also something that can be approached from higher level where you have some abstraction in place, and so we use Kubernetes and Helm, and we have the scripts are sometimes common, and maybe the tools are going to be different behind, but you definitely can scale horizontally with more protocols, and adding a new protocol is not going to be maybe 10, I don't know. If you spend 1 year supporting Pocket that way, maybe supporting another protocol in the same way is going to take, let's say, 2 or 3 months instead of a year, and so on. Other questions for automation? Okay. And finally, I'm going to talk a bit about instrumentation. So it's instrumentation is what you need to get metrics to know what to do with those metrics. For instance, I mentioned before that we had automation to stake or unstake or like unjail a node, and to be able to automatically unjail a node, you need to know that the node is jailed in the first place. So you need to have like some sort of metrics that are somehow fetched from production. We use for this Prometheus. Prometheus is some sort of internal thing that was used at Google, which was made open source a few years ago, and there is like an open effort to distribute this everywhere. And Tendermint has a support for Prometheus as well as some parts of POKT, but not everything we need. So we also have our own instrumentation on top of it. So to get this instrumentation, what we do is we have a sidecar process. So it's like a process, like a Go process, which runs at the same time of a validator. And every 5 minutes or so, it's going like to poke the validator, get its state, and like try to get more information from it, and then publish it to Prometheus. And with this, we get like new sets of metrics we can play with, like even business metrics, which are like not very technical. So for those who are familiar with like Ethereum and Prism, it's a bit like client stat, I think, or there is something like this which uses the same approach on Prism.
Yes, yeah, it's like Prometheus Graph Prism open source way of monitoring it.
Yeah. So this is some like example of metrics we fetch that way. And like because it's a Go process that does this, it can do whatever we want. So what we do is, like one of the problems you have when you run like validators like this is that you don't know if your validator is wrong or if the network is wrong, if there is some issue with the network. So you need to compare your current state with the state of the network. So you need to have like your monitoring be aware of both sides and take decisions based on those. Like for instance, if you have one node that is like at block 20 and you see that the network is at block 30, you know that your node is late and there is a problem with your node. But maybe, basically you need like to have two sets of data to compare them and then take decisions. And for this, like having custom instrumentation is very helpful. And so for those who are familiar with Kubernetes, I don't know if there are many people familiar with it here, but the Sentinel, so the sidecar process that was mentioning is exporting an HTTP endpoint to tell whether or not a node, validator node is healthy or not. And you can configure Kubernetes to poke this endpoint every now and then. And depending on the return value, it's going to take an action. And the action can be restart the node. And this is how we basically detect late nodes. We have like the Sentinel that exports the healthy, compares the current state of the node with the one of the network. And if it's like stale for more than 30 minutes and late for more than 30 minutes, we decide to restart the node. And to do this, we define a probe that is like, this is how we define a probe on Kubernetes. And so here it's actually different numbers. It's like every 10 seconds, we are going to poke the Sentinel. And if it fails 15 times in a row, we are going to automatically restart the node. So next steps for instrumentation, maybe, we're thinking about maybe open sourcing the Sentinel if some people are interested in this approach. And we're also working on having some sort of real-time visualization of our topology, where the Sentinel basically can scan all the peers of a node and push them to like a graph database, and then we can like have some sort of real-time representation in 3D or whatever. There are like cool frameworks for this. I think that's all I have to say. Sorry, that was a bit technical and fast, but if you have any questions, now
Hi. Nice presentation. So Sentinel will get metrics from the node, and then Prometheus will scrape Sentinel, right? So like it's a middleware sort of. Why not create a Prometheus endpoint for the node itself? Because you want to choose to...
Because like we don't touch Pocket code directly. We prefer to have our own instrumentation. Like we don't want to fork Pocket and like have a terrible bug because we had some instrumentation inside it. So we don't have control on the, we're just running Pocket nodes. So we prefer to just use the official version of Pocket. Yeah. So that's why we don't instrument ourselves Pocket.
And how does Sentinel takes the data from Pocket?
So we usually use, so there is a Pocket CLI, which like you can have commands like Pocket query node or whatever. Right. And it's going to give you some status about the node. And yeah, and also another reason is that if the validator is running and suddenly like totally irresponsive or exporting stale metrics, you're not going to detect it if you don't have another process that is like totally safe, not safe, but like, I don't know, if there is a bug where the validator is completely stuck, Prometheus is not going to detect that something is wrong, right? Because the process cannot export the metric, so there is a sort of chicken and egg problem. So that's why like having two processes is better.
If the node is stuck for some reason, then the metrics will get stuck. So Prometheus...
It can be a bug, like, yeah.
You will see, I mean, if you have the Grafana dashboard, you will see the metrics start not making sense, right? You will see like, why this chain head is stuck at...
Yeah, you will see something, but like if you build automation on top of it, like you have to take decisions on like data you...
On the alert manager level, like what's the threshold? Yeah, okay.
Yeah, so for alerting and monitoring, yeah, it's perfectly fine. But when you start taking decisions, like if the node is not responsive, like you don't know what state it's in, so you don't want to, like, whereas if it's a separate process, you can know kind of like the state machine in which it went, like maybe it was jailed and it was unjailed and it started like...
And add more business, like more custom logic inside Sentinel, so you can have more advanced and easy alerting on top of that.
Yes.
Yeah, okay, that makes sense. Thanks.
Any question? No? Well, thank you very much.
Oh, there's one question.
Sorry about that. I have a more general question about Pocket. You said you have 4,000 nodes in the network, right? Do they come with packaged Ethereum full nodes, or how do they do queries to blockchains?
Yeah, so the ratio, I don't know what the ratio. Oh, yeah, thank you. So that question was like full nodes versus validators on the network?
Well, I mean, like the value proposition of Pocket is decentralization from Infura, right? So there should be many Ethereum full nodes that you query in the end, right? Because if you just have a lot of nodes that all send requests to Infura in the end, then like what's the value, right? Yeah. So I was trying to understand the kind of the numbers here. What amount of full nodes being run by Pocket Network, Ethereum full nodes, or how does it achieve decentralization in a different way?
Yeah, I mean, maybe Seb, how do you guys Pocket validators versus full nodes that you guys run?
How do we? Sorry.
Like so the ratio of validators versus like Ethereum full nodes.
So I think it depends on the performances you want, but of full nodes, sorry, you mean ratio of like Pocket validator versus Ethereum full nodes, right?
You know, the question is, Infura is a company, right? Like the value proposition of the Pocket is we decentralize Infura. Infura is a company. Infura in AWS runs a lot of Ethereum full nodes, and they have Kubernetes. They all have all this stuff, right? It ends up with a single endpoint that we all query, and we all happy, but we are not happy because it's not decentralized. So I was trying to understand is Pocket Network gives me ability to query one of these thousands of nodes in the network randomly. But these nodes these Pocket Network nodes should in the end query some Ethereum full nodes, right, to get the data from the state. So, and I was trying to understand like how many of these nodes in the end?
I think there's probably somewhere between 500 to 1,000 Ethereum full nodes to our 5,000 Pocket nodes.
So basically, it's a 10% of Ethereum network.
Yeah, it could be. Yeah, I mean,
On our side, I think it depends on different node runners or different setups. On our side, like just for SkillZ, we have a cluster. Like we probably have 5 full nodes of Ethereum, like with very big configurations, and we can scale them up if it's not enough. But yeah, for us, it's like, but maybe different setups have different needs. So.
Yeah, but I guess as well the like proposal to be decentralized, the number of full nodes spin up by Pocket is like Ethereum full nodes is interesting, but at the end of the day, Infura might, I don't know, run 200, 300 full nodes for what, several billion requests a day. The thing is, it's so centralized, right? It's AWS, maybe 1-2 region, that it happened before, or even using the same Ethereum clients get. If there is a problem with a client, if there is a problem with AWS, if there is a problem with a region, they might run 1,000 nodes, the whole service will go down, right? The thing with Pockets is that even if you have, I don't know, 5, 10 nodes through the force big provider that actually support Pockets, because you have obviously smaller node provider or even single node runner on Pockets. But at the end of the day, what makes the topology stable and the whole system performance is 4 to 5 very good node runner. If one of these node runner goes down, obviously the network will still remain. And if 2 of these big node runners goes down, same thing. So I think this is really a kind of advantage, or even like this is really a kind of progress that you see on Pocket and that you don't see on Alchemy or Infra or any centralized way of accessing blockchains.
So, like, if in the end there is fewer Ethereum full nodes than Pocket nodes, then what's the reason to have the Pocket nodes besides just load balancing between those full nodes?
Yeah, so every Pocket node has the same chance of doing work as every other node. So the minimum is 15,000 Pocket, so you're incentivized to continue replicating your own Pocket nodes as you continue earning Pocket. So you might have 5, 10, 20 Pocket nodes, or in their case, hundreds to one single Ethereum node, right? But you are incentivized to actually split up your validators due to the way the economics work.
It's going to look very different at scale, right? So right now, Pocket's not actually processing a huge amount.
Yeah, it's like 1%. Like we're not even probably using 1% of the compute of the network right now. Yeah.
Surely, I'd imagine that it could be 1 Pocket node to 1 Ethereum node in the future.
We don't know what that ratio might be, but yeah, we'll see as we grow for sure. Hopefully did answer your question?
Yeah, maybe. Yeah, I maybe ask more questions after. Okay.
Cool.
Thank you.
Yeah.
What is like the latency of Pocket compared to other like providers like Infura?
Yeah, good question.
It seems like this seems like pretty complicated.
Yeah, so in Pocket you're querying just a raw full node. So right now we're between 300 and 400 milliseconds for most requests. And Infura, Alchemy, they'll probably serve you some data depending on the type of request between 150 and 250 milliseconds. That's usually because they have cached data or indexed data. And right now, at least with our node runners, it's just a raw Ethereum node. Eventually, we'll release some packages that allow the node runners to have some local caches, indexes, and so on and so forth, where we'll kind of get to parity on that front. But that's kind of the kind of difference right now. Just for context, when a page loads, you usually, the human site doesn't perceive it between, until after 250, 300 milliseconds, as an example. So it's pretty, it's pretty fast. It could be faster, and we'll get there over these next kind of 6 to 12 months.
Okay.
Yeah, good question.
Any other questions?
There's been a lot of talk about MEV lately, Flashpots and all sorts of stuff. So, a lot of towns they say, don't use Infura. Because you want to run your own node to be the fastest, or maybe the infrastructure will actually front run you. So I was wondering, have you done any research on that front? How are you thinking
Yeah,
about that?
we're still early in thinking about it, but node runners are in an interesting position in Pocket, given that issue. I think there will be some opportunities. I'll be honest, we haven't looked super deeply into it yet. Other than I think there will be some interesting opportunities for Pocket with MEV and this kind of thing for sure. So. Just because it's a network of people running, these nodes, and they're the ones receiving the transactions, right? So whether it's applications, in the future being paid, right, for certain things, right? So
would it be possible for I'm not sure how Pocket exactly works. I'm super new to this, but I was wondering, for example, Flashbots, as a miner, you can sign up so you can receive bundles from Relayer. I imagine that Pocket would be like a single interface to that relayer. So that would make sense. Have you thought about yeah?
Oh, I'm sorry. What was the question?
So the question is, I'm just thinking right now. I'm trying to see if it sticks. How Flashbot works basically is that a miner can receive bundles of transactions through the relayer. But I imagine from the outset, Pocket is a single miner, like it's a black box, right?
Well, in this case, Pocket would be the relayer, not the miner, right? You're running full nodes, not necessarily validators.
No, I think no. It will be the relayer. It's just a private entity that basically tells you that I will not leak your bundle. Yeah, and now it's trusted by the Flashbot team. You can send me the bundle, and I will not front-run you. But the miner might. I don't control that.
Gotcha.
So maybe it would be interesting, if the Pocket network could hook into that Flashbot, so random Pocket, they would receive bundles or whatever. I don't know.
I guess we had Flashbots on Tuesday, and as you said, if you want to do MEV through Pocket, Pocket will be the relayer. So in spite of a full node, Ethereum full node, you will need to run a validator, staking validator.
Yeah.
And the staking validator will install Flashbots and read the bundles from a transaction that has been relayed by Pocket, right? And in this sense, maybe MEV could work, but again, the bundles, I think, won't be read on the Pocket network. You see my point?
Gotcha. Yeah, I think. Okay, now I see it.
We are a relayer,
Yeah, right. You're a relayer.
We just relay these.
Interesting.
These RPC requests.
Cool.
It's really thin middleware.
Yeah, I gotcha. Yeah, you're right. Sorry.
Yeah.
Cool. Thanks.
Questions?
Thanks, everyone. Well, thanks for coming.
Yeah, mushrooms at the end. So we'll have some fresh beers if you want to stay, and obviously there's a terrace also upstairs. I'm not sure we're allowed to go, but let's say we do. So again, thank you very much for coming. Thank you for Pocket to move.
Yeah.